Hello, my name is Geonhui from the Line CSERT team. I want to talk about what Line security strategy is for integrated security on on-premises and public cloud environments. Designing a security architecture considering a hybrid multi-cloud environment is today's presentation. We also have Seungnam from Line Infra Protection team that will be my co-presenter. First, I will talk about the content and the scope that will be covered in each section during the agenda. We will explain the background of Line's need of hybrid multi-cloud security design during the public cloud. In addition, we will mention 6 key keywords of Line that were considered important in the design process of the hybrid multi-cloud architecture, and about 5 technical security designs related to the keywords. First, let's talk about the design of integrated cloud IAM for access control and resource control. Second, the management and lifecycle of cloud service account keys, which is very important in cloud security, that is the lifecycle. And third, Seungnam will explain the network connection between Line's on-premises and public cloud based on the actual implementation case of Line. Fourth, with regard to cloud log collection, Seungnam will also explain an application of a central collection method based on organizations of the AWS CloudTrail logs. Fifth, we will talk about the posture management approach to security monitoring for incident response in cloud environments. And finally, I would like to conclude with a summary and also talk about our future goals. Why don't we start the session then? Why did Line use a public cloud environment? And did it become necessary to design a hybrid multi-cloud security architecture? What kind of environment does hybrid multi-cloud mean? Today, the definition of cloud computing goes back to 2011. NIST, the National Institute of Standards and Technology in the United States, definition is followed by most companies. So depending on the infra deployment model, the terms private cloud, public cloud, and hybrid cloud are used. However, the report did not mention the deployment model associated with on-premises, and there's no industry standard terminology. So there might be some differences in terms that many IT companies refer to. But Line defines it as the following. It uses IaaS-based public cloud provided by one or more cloud service providers, the CSPs, and defines hybrid multi-cloud as a network connection between on-premise and ring topology. And amongst the deployment models of NIST, there is no problem even if the concept of hybrid cloud is expanded and understood as the same thing. Line operates data centers in various countries and uses Verda, an NStack-based private cloud for Line services with its own technology. But why did Line end up to choose to use public clouds such as AWS and GCP and Azure? First of all, Line always strives to expand new services or regions to its customers. But due to legal regulations, it's difficult to utilize the existing on-premises environment. Of course, you might think, why don't you build more data centers? The time and effort and cost to build a new data center will be proportional to the legal regulations of the country where the service is required. And building a new data center will be difficult because it is difficult to predict whether the product will be successful. Therefore, the company decided to go with the public cloud. Second, because of the Line's cloud-native DevOps development culture, Line develops services in the form of sustainable and scalable container-based microservices, and developers want to utilize a variety of open-source platforms aiming for the cloud-native ecosystem. An example would be Kubernetes. If it's the existing method, a platform configuration is required in the data center. And to enable developers to use on-demand self-service, a lot of resources are required for initial deployment, config, and maintenance. And there are increasing cases where IaaS, SaaS, PaaS infrastructure provided in the public cloud want to be used in the CI or CD implementation process. Third, it's because of M&As. If the acquired company service was operated in the public cloud and attempted to migrate to on-premises, but due to the nature of the cloud, it's difficult to lift shift due to the complexity of the service. The public cloud environment has been maintained as it is, considering the aspect of the service's uninterrupted availability. In other words, it has become the subject of lines management and the security team. Of course, M&As aren't frequent, but there may be similar cases in the future, so the security team needed to prepare for these. CSP refers to cloud service providers such as AWS and GCP and Azure. And each CSP's cloud infrastructure architecture is not the same for all vendors. What does that mean? It means it is difficult to integrate and operate. And the hierarchical structure of resources, the structure of the authentication directory, and the way cloud users control the cloud differ from company to company. And there are differences in the security functions applicable to each CSP, so the security framework must be configured differently for each company. For a company that uses multiple CSP multi-cloud environments rather than a single CSP like Line, this is a tremendous risk. It means more complex the infrastructure is, so does the security risk increase along with various operational risks. The difference in architecture between each CSP leads to a difference in the management function method, but the same security design cannot be applied to each environment or middleware for the management is required at the center. Line currently has more than 100 units of CSP accounts and projects, and more than 1,000 units of developers based on cloud environments, which is increasing every day. Therefore, since many CSP accounts have to be managed and engineers and developers based on various roles have access to common resources, if you don't plan for cloud security in the early stages of operations, you can lose visibility very easily. During today's session, we have limited time, so I ask for your understanding if we cannot cover all parts of cloud architecture design. Before we get to the main point, here's a report of the research results of 11 leading threats in cloud computing environment released by CSA in 2019. If you're new to cloud security architecture, I think this will be pretty informative. To prevent the top 11 threats, a cloud security strategy is essential. So let's look at the top 5 threats. Number 1 is data breaches. 2, inappropriate change control and misconfiguration. 3, cloud architecture design strategy. 4, a lack of management of cloud credentials. And 5, cloud account and service account hijacking. So what are the solutions for these problems? Using the public cloud environment for your service, you may be exposed to the 11 security threats reported by the CSA. So let's go to the main part of the session. What part did Line consider important in designing a hybrid multi-cloud security architecture? Let's talk about the 6 important keywords for design. The integration of IAMA, so IAM is very important. In order to integrate the cloud environment provided by different CSPs, you must be able to control access according to the identity. Who, when, where, how can they access to which resources is possible while giving the least amount of access. In some cases, access control according to the source IP, vulnerable times, or other things may be required as an additional condition. An additional MFA authentication may be required for access to specific resources. Since it is a hybrid environment, synchronization of authentication information on the on-premises identity directory may be required. And after the COVID-19 pandemic, it is necessary to access the cloud console through appropriate authentication. And it is necessary to consider using a third-party provider such as IDS so that it can be accessed through authentication from anywhere, even for remote working. And since service account management is also done through IAM should be designed from the perspective of making it impossible to reuse keys through lifecycle management. The management of cloud keys is very important, so we will be covering this in detail later on. The second keyword is the on-demand self-service. Line allows developers to use services they need for development at any point in time without the intervention of the admin. So is the design of the private cloud environment. Therefore, the role of the security department is even if the developer creates the various resources using the services of the public cloud, is to prevent resources from being provisioned in the state that violates predefined security policies, such as controlling them by explicitly blocking them technically. The third keyword is a concise network design should be carried out by connecting a dedicated network between on-premises and public cloud environments. In terms of security, the biggest advantage is that you can use a private endpoint provided by the CSP instead of transmitting data to a CSP endpoint that everyone uses. In addition, the structured design of network access control can maintain the existing on-premises control policies, such as the allow list and deny list. It should be designed in consideration of quota and capacity. There are hard limits and soft limits in the quota, and in the case of soft limits, it's possible to adjust the possible capacity by consulting with the CSP. And it is commonly known that quotas are limited on the premise that cloud resources are controlled through APIs and excessive costs are prevented. However, there is actually a limit on the capacity of cloud resources provided by CSP. And if you need to use a large-scale compute engine in a short period of time, you may be asked to wait because the region cannot handle it. If you don't know the quota and the capacity in advance, there may be an accident, the service stopping due to the quota. Or if you create a system that collects separate resources, the number of requests are rather limited, making normal security monitoring impossible. Fifth, it should be designed so that the structure can manage the infrastructure as code. In the cloud environment, inventory resources are managed as data structure, and the entire cloud infrastructure can be reviewed in code form. It is a structure that makes it easy to create the same infrastructure by replicating the current settings and provisioning them in another cloud environment using Terraform or Ansible. Therefore, it can be understood that this design should be considered with a structure that can lift shift the service. The DevOps development methodology has a container-based microservice type deployment model. If it is designed in a structure in which people can only manually control specific rights of the cloud during the service deployment process, it may prevent stable service operation by not passing through the branch. Therefore, security must be designed in consideration of provisioning infrastructure with code when designing. And if the risk is decided necessary, use measures to solve them through various ways of monitoring. All resources inventory in the cloud environment can be managed by code So changes in all resources must be monitored and utilized for change management, internal violation monitoring, and security incident monitoring. Next, we will talk about access and resource management in the multi-cloud environment. First, this is a story about the identity classification system in the cloud environment. Line categorizes identities into two, human and robots. Further, we should talk about accounts for controlling the cloud environment. Cloud accounts are divided into user accounts and service accounts. In other words, in the case of a user or a developer, authentication must enforce the IDP, the identity provider, such as IDS, and a multi-factor authentication method to use the cloud console. The problem is, in the case of the robot, such as computers, in order to implement a service linking with a public cloud in an on-premise machine, you need to use a key type service account. There are many cases where the reuse of the key becomes a problem due to an external leakage. Therefore, it is essential to establish a strategy for how to manage service account keys in a cloud environment. And we'll talk about service accounts later. For authorization, by defining appropriate tags and labels for IAM role and policy, the cloud resource with the principle of minimum authority, it can be implemented so that access to the previously permitted resources and businesses use are possible. And there are three main things that are important to the strategy of IAM design. First, creating a security hierarchy for the management of multi-cloud CSP accounts, because it is to inherit the higher security policy according to the hierarchy and to limit the scope of the accident threat and convenience of management. Second, the appropriate authorization based on cloud resources. Failure to prevent excessive privileges from being granted may result in serious damage to account hijacking and leakages of service account keys. Third is the management of cloud user management and authentication. Account management in a separate identity directory provided by AWS IAM user or CSP can increase the risk by increasing complexity. Therefore, authentication integration through single sign-on is essential. Line's AWS resource and multi-account hierarchy are organized as the following. Depending on the staging of the project, not the usual three-tier production, staging, and development, but the production and dev are designed in a simple two-tier format to accelerate the developer speed. An AWS account required for security and operation is created in a separate managed OU to monitor cloud trail logs and security solution management location and metrics. And in order to implement the single sign-on on the multi-cloud console, you need to understand the structure of managing the identity of each CSP. And there's a big difference between AWS and GCP, as you can see on the screen. The identity directory. In the case of AWS, every account has a directory that manages the individual identities. The GCP is an account system in units of projects, and the identity directory is externally separated and a single configuration is possible under GCP Cloud Identity. So Google CP or Cloud ID, these are different names. Therefore, in the case of AWS, by using AWS single sign-on service to implement integrated authentication, one more upper layer is created, and the IDP performs initiated SSO to the AWS SSO, and the developer pays access the role through the workflow. In addition, the developer has implemented AWS credentials so that they can be issued and used for a certain period of time on the console. And let's look at the screenshot screen that was implemented in the same way as the real environment. In this screen, you can see the developer logs in using a work account through the IDP and receives a multi-factor authentication and access the SSO page. You can selectively access the console based on the role of each account assigned to you. And of course, the session timeout is set very short. This is a scene of acquiring AWS credentials on the SSO page, and it can be only used during the session time of the predefined role, and then when the time expires, the key can no longer be reused. The developers can use assume role token to conduct cloud development tests of their choice. And this is a scene using the AWS using interfaces such as the AWS client. The multi-factor authentication must be obtained, and the session timeout is set as short as 1 hour. So for GCP, this has an independent identity directory. So it is important to manage IAM permissions for a single identity in each project. And in the case of GCP, you must receive MFA authentication using the IDP SSO method using the Google Cloud Client interface, and then use the console. Next is the Cloud Service Account Key Management. There are two types of service account keys in the public cloud, and one is internally managed by CSP, and one that the users can download and manage directly. For developers, AWS IAM user credential is required. And there may be cases where you need a service account key that can be used for a long time due to security solutions POC. So what should you do in this case? Can a developer directly issue and use the account, or should we issue it for them? When using a service account key to control public cloud services on a server in an on-premise environment, and when a developer needs to operate a system, the key is issued using the following key management solution with the open source HashiCorp Vault. The most important purpose is to hard code the credential into the service to prevent it from being reused without rotation. So for developers, passing IDP authentication such as IDS and LDAP and accessing HashiCorp Vault, you can download the service account key of the policy specified for AWS and GCP accounts that have been approved in advance. Of course, only predefined period of times should be used and reissued. The lifecycle of the key is managed by HashiCorp's Vault's dynamic engine. When a service account key is required in server and application classified as on-premise robot, the key is rotated using the HashiCorp Vault system and reuse is fundamentally blocked. Next, Seungnam Jun will be explaining the case of Line's hybrid cloud network and central cloud log collection. Hello, my name is Seungnam from the Line Infra Protection team. I want to talk about the hybrid cloud network environments configured by Line. Line has been demanding rapid expansion and construction due to the business demands. And so when Line introduced the cloud service, it decided to configure it with the concept of IDC and extension. We have connected AWS Direct Connect for high speed and consistent network performance and improved security through dedicated network communication and easy expansion. The AWS Direct Connect is configured to connect the data center and the cloud service provider of Direct Connect location. And through this configuration, when Line receives a request from the developer to build a cloud server, it's shown as the slide. The network configurations such as VPN availability zone and subnet are created by Line's network team, and then when the creation is complete, it connects with the Direct Connect. And EC2 is built at the IT service center in charge of Line servers. And if internet connection is required, connect according to the communication environment as shown in the slide. And finally, the security team provides the AWS environment to users after setting up additional security services. Line's long-standing operational experience in the on-premise environment can be used for the cloud. Through hybrid cloud, it has become possible to have consistency between the on-premise environment and the AWS operating environment. And the management tools used on-premise can be used as they are in the AWS environment. As shown in the figure, it is now possible to securely connect to the on-premise server through private communication through a dedicated line between the cloud server. Hybrid cloud network environment configuration, on-premises and cloud, became an environment that communicates in one data center. The cloud server can also be connected through the existing server authentication method. If necessary, internet communication can also be performed via EC2 through a dedicated line. Since network separation is required for each service in a hybrid cloud network environment, each VPC is created. There's difficulty in creating this VPC and managing each BGP peering between AWS Direct Connect locations. You will need a number of NVPCs and NBGP peerings. And there's a hassle of having to connect to the IPsec VPN to connect overseas regions. So looking for a simple way to manage this, we have come up with the Direct Connect Gateway. You can connect 10 VPCs per Direct Connect Gateway. Direct Connect Gateway supports multi-accounts as a limitation. The VPC connects to the Direct Connect Gateway and cannot communicate between VPCs. Line does not require communication between VPCs. And for services that can communicate on public networks such as AWS Lambda, Elasticsearch, and DynamoDB, you can communicate privately with Direct Connect gateways and public virtual interfaces. For reference, there's a method for communicating between VPNs, which is a limitation of Direct Connect gateways that was shared earlier. When connecting to a VPC through AWS Transit Gateway services, it becomes an environment that can communicate with each VPC. An AWS Transit Gateway is a configuration that communicates with the allowed VPC when opened in a specific VPC rather than connecting to each other like VPC peering. Now, I've been talking about the network environment of Line, and I want to talk about the central collection of AWS logs from now on. A centralized log collection is very important in a multi-account environment. Users can quickly detect the AWS configuration changes, and the individual users cannot arbitrarily corrupt logs. To briefly explain the configuration, CloudTrail logs of multiple accounts connected by org are collected and stored in one place. And this saved log is transmitted to the security admin or the system admin log system, depending on the type. Let me talk about an actual case. CloudTrail tracks all APIs occurring in the AWS infra. You can see the user who is called, the API, the source IP, where the call started, and when it occurred. So you can track changes made by the API request. Now, let me talk more about the log collection flow. The CloudTrail event of individual accounts are stored in the S3 of the central log collection account. S3 sends event notification to SNS, and the SNS sends to the SQS to log queue. It is configured so that there's no log loss through SQS, and the information stored in the SQS is brought through an external log system, and the data is read, and the log data of S3 is saved. Line creates two cloud trails for each account. One is the security log that contains KMS to be used for security purposes, and the other is a log that excludes KMS to be used by AWS service personnel. The AWS Service Manager uses CloudWatch, Lambda, and Elasticsearch, and separate logs are stored there. If you put together the configurations mentioned above, this is how it looks like. The two CloudTrail logs for each account are created and sent, And Line uses Log Gateway to retrieve AWS security logs and send them to various security log analysis systems for log analysis and real-time monitoring. Line's hybrid network environment and central log collection and monitoring would probably give you some ideas about operating your environment. We have to explain about how to collect the central log of Line. Next, Connie-님 will continue to explain about the posture management. Posture management is used to detect and prevent security incidents in cloud environments. In other words, it's necessary to monitor resource change and to treat individual resource changes as raw events like IDS detection events to monitor accidents. So I and Seungnam have been talking about the line security architecture, especially on the public cloud architecture. And these architectures are created and applied on the service to make sure that there are no architecture breaches. And in order to reflect the demands that we have, I wanted to talk about what kind of efforts are actually being carried out. So in conclusion, the security management has to be done by posture management. CSPM is a cloud resource configuration management system. The security assessment and the compliance monitor can be performed across the cloud stack, and the cloud security risk can be identified and resolved in advance. As multi-accounts are increasing and the complexity of the environment increases, it's necessary for organizations that need to properly configure public cloud, IaaS, SaaS, and PaaS services address those cloud risks. And its main functions include functions for compliance monitoring, incident response, and risk assessment and visualization. As the cloud infrastructure is constantly changing to reduce cloud security threats, CSPM is used to manage changes in one resource for hybrid multi-cloud environments, identify differences between specified security policies and actual security statuses, and provide events to admin. It notifies or performs a predefined action to keep the enterprise cloud environment safe. Since CSPM includes a function to plot the organic relationship between resources in a complex cloud, visibility of the cloud environment using multi-accounts is also secured. And the history of the changes of cloud resources can be tracked in the prevention and post-response of security incidents. Open source and commercial software exist. And in the case of AWS, the configuration management of organization-level cloud resources is possible by using AWS config. And I think it hasn't been that long since it has been possible. In the past, using SecurityMonkey, released by Netflix as an open source, many companies managed to manage their resources of their public cloud operated within their organizations. However, with the AWS config service opening, we are using AWS config a lot to continuously ensure compliance and find configuration errors to protect our critical cloud assets and to maintain visibility. What about GCP? GCP uses ForSeti security provided by Google as a open source, and the resource configuration management can be performed for the entire organization, and violation of internal policies can be continuously monitored. Other commercial software such as Geonhui and Prisma are also available. In order to centrally monitor various cloud environments and perform unified monitoring, it is also a method to use commercial software that supports various CSPs. Line is currently using various CWS such as AWS, GCP, and rather than improving them one by one, we're using one integrated commercial software or an open source software so that there is a unified policy that is used for performance enhancement. And in order to effectively monitor the security of cloud environment and prevent breaches, in addition to user behavior-based logs, host-based security logs, and network-based security logs, 3 event logs must be collected, monitored, and continuously observed. So the user behavior log is a traditional log that is used to find out which employee activity had caused the breach on the on-premise system. And for host-based security logs, they're trying to find who has created the breach on the which host activity. And the network-based security log is an on-premise system. And so it's utilizing the IDS or the C logs in the infrastructure are so collecting various types of logs or metrics. But for cloud, it's impossible to manage the metrics or the surfaces of the infra or ES surfaces. Therefore, we have to utilize the various logs that are provided by the CSPs. And the 3 types of data that we collect are the following. It can be used as an event to distinguish between normal and abnormal by using billing information of cloud billing rates. For example, if there's a certain service charge increase in a specific resource, you may suspect there's an external leak of the service account key or a zero-day account attack. Maybe the service is very successful. And then there's security monitoring of the cloud activity logs are also required. For example, if a specific service account attempts to request permission to a cloud API endpoint that has not been used before, you can suspect a security incident. So you should utilize these kind of logs. And in addition, the cloud configuration management event should also be used as a single raw event to monitor complex cloud environments. Lastly, I want to talk about our next steps of our service. What kind of goals, future directions do we have for our platform? SOAR, the Security Orchestration, Automation, and Response System, is going to be used to automate incident responses in a hybrid multi-cloud environment. This is currently in preparation. It targets the IaaS environment of multi-CSP accounts and minimizes the human effort involved in accident investigation by automating the process of incident investigation, isolation, and mitigation measures based on playbooks for instances and Kubernetes cluster nodes operating on a VPC. And we are conducting research on ways to continuously advance the rules of the cloud configuration management system used within Line. Because cloud resource configuration management monitoring operates according to predefined rules, periodic management of detection rules and efforts to improve detection rules are required. It is necessary to think about better ways through continuous interest and learning about evolving public cloud services. Thank you very much for listening. Our presentation was about the security architecture design for hybrid multi-clouds. I was Geonhui from CSIR team and also Seungnam from the Infra Protection team.